today's webinar on challenges of space engineering and space technology. This webinar is being organized as a part of series of webinars that started during COVID pandemic to take advantage of lockdown to reach renowned resource persons globally and get their experiences shared with the students and faculty of Amity. These activities started with the blessings of founder president and motivation given by Honorable Chancellor and Honorable Vice Chancellor of AUH. Today's webinar is being delivered by Dr. Kumar Krishen, PhD Fellow, Society of Design and Process Science Associate and also Associate Fellow, American Institute of Astronauts and Aeronautics and Astronautics, Fellow and Distinguished Speaker, Institution of Electronic and Telecommunication Engineers, Adjunct Professor at the University of Houston, USA, NASA Exceptional Service Medal recipient, and former NASA JSC Chief Technologist and Senior Scientist. Sir, hearty welcome to you for this webinar. Let me introduce Dr. Kumar Krishen. Dr. Kumar Krishen holds the appointment of Adjunct Professor at University of Houston, USA, and Honorary Distinguished Professor at Amity University, Haryana, India. And he is also Honorary Professor at Delhi University, Technological University, India. His academic degrees are from Kansas State University, PhD, and MS Phi from Kappa Phi, Eta Kappa Nu, and Sigma Xi Honors. Kolkata University, MTech, and BTech Gold and Silver medals, and Jammu and Kashmir University, BA, highest university in merit in electronics and electrical engineering, and he studied radio physics, physics, and mathematics in that course. Dr. Krishen taught and guided research at Kansas State University before joining Lockheed in 1969 as a staff scientist. Dr. Krishen was with NASA from February 1976 to September 2018, a very long journey, and held key positions in advanced programs in Earth observations, science payloads, experiment systems, tracking and communications, mission support, new initiatives, exploration integration, and science and technology research and development. He has authored more than 170 technical papers and articles and proceedings on various topics related to space science and technology. Dr. Krishen is a recipient of many awards and honors from universities, industry, and NASA, including NASA Exceptional Service Medal. Dr. Krishen was nominated by Governor George W. Bush and confirmed by the State Senate of Texas to the State Texas Board Licensing for Professional Medical Physicists in 1999 and continued to serve on this board under Governor Perry's administration till 2011. Dr. Krishen was also awarded with Bharat Samman, the highest honor given by the non-resident Indian Institute in 2006. The award was presented by His Excellency Sri Michael Arthur, KCMG, the British High Commissioner to India. He was awarded with Hind Ratan, the highest award given by NRIW Society in 2008. The award was presented by Honorable Sushil Kumar Sindhe, Union Minister of Power and Government of India. We also have with us our Honorable Vice Chancellor, not in the panel, but he is there in the team here, who is a source of inspiration to all at AUH, and hearty welcome to our Honorable Vice Chancellor, as well as Dr. Kumar Krishen. Sir, for you now, you can take answer. Thank you very much.
I want to give my warm thanks to Amity institutions, and I have such a regard for Dr. Chauhan and his family, and this particular invitation is from very great personality, Vice Chancellor Dr. Sharma, and Dr. Sridhara did an excellent job of coordinating, keeping me on track. So I want to take only that much time. Again, thanks to Amity institutions and all the people who are involved, faculty, students. I really am so impressed with you all. Today we are going to have fun, and we are going to talk about challenges of space engineering and space technologies. This is the topic that was chosen by Vice Chancellor Dr. Sharma, such a great personality. So we will cover in this talk the following. We will talk about space exploration in the next few decades. This presentation is based on my work and the work of my colleagues at NASA and industries that support NASA. But today I'm not talking on behalf of NASA. So whatever I am saying is from me to you, although I will be using the charts that mostly come from NASA. But the space exploration in the next few decades is my view of how I see the next frontier being expanded and exploding, and that will be the space frontier. Thriving in space, I don't know if you are able to see, there's an article just came in Aerospace America. The issue is November issue. I'll be talking about that. Then in various ways, 2-3 different directions, I will come to the topic of key technology needs, particularly for going to moon, staying there for a longer time, and you will see what I think will happen on the moon, and then having Mars, human missions to Mars. So we'll talk about future technology challenges in that context. Particularly, one of the tallest poles for technology and mission execution is space radiation, so I'll spend some time on that. I will end this presentation by giving you some very selected, actually, I had like 40 slides. I selected only about 8 or so to tell you that there is a lot of technology needed, and that development, engineering and technology development, give you a flavor in those 8 or so charts. Now, the first thing is my idea of coming to NASA was to understand what is universe. And to this time, I haven't really even scratched the surface, but it's kind of interesting to see that, you know, we're talking about universe was a small little thing, then it exploded, the Big Bang happened, then some people calculated like 9 billion years, some calculated 13 billion years, some are going past that, etc. But honestly, we do not know the exact timing of the birth, to how the space was created, how energy was created, how matter was created, and finally, what is even like the Mount Everest of understanding universe is life. How did life come about? I want to digress here a second. In our scriptures in India, if you go past, there is a time scale given from Truti. Truti is 1/10 of a nanosecond, which is like 1 divided by 1 and 10 zeros. That is how in India time, the littlest time called the atom of time was defined. And it's a surprise to me how they came up with that number. And then what they're saying about time is an ingredient without which you cannot make anything. That's how our philosophical way of looking at time is. And I wanted to end that if you go to the scale, there are yugs given and many other things given. We're going through what is known as Kali Yuga at this time. But at the end, what is so fascinating to me, the entire life of universes is what they call the life of Brahma. And I did a little calculation, and it turns out to be 3.141592, etc., trillion years. That is how much we think the scale of the universe, total collapse of universe and new universes will come in. That is pi. Pi is something you use when something comes back. So you get the hint. We had some great thoughts about universe long time back. So in this scenario of exploration scenario, I will talk about Earth orbits, how much concentration of assets will take place. Then I will talk about moon. Moon will be the next staging place for a lot of exploration that will happen. And Mars, human missions to Mars will be key because there's some hint that life existed on Mars sometime before and may even have some remnants of that life even now. We will also talk about asteroids because there is a search now that there may be certain expensive metals, maybe things like that, that will be very unique and could be brought back to Earth. Again, asteroids are also interesting because they can hit the Earth and we will be in great trouble. Then this picture you see on the left, on your left bottom, is black holes and Milky Ways and all these different things that we want to explore in the universe. So let me quickly also say, when I joined NASA, I was very fascinated with these Lagrange points. And in fact, in my papers, if you go back, I talk about Lagrange points, L1 and L2. What's so unique about Lagrange points? And I have some students joining, hopefully, who are still in high school and some are in the college. So I will say this, that a Lagrange point is where the pull of the Earth and the moon is equal. And therefore, when you put an asset there, for example, a satellite, it will stay there. For example, a rocket or anything you put. So that is the attractive part. For the students, I'll say this, that when you have International Space Station, it keeps coming down slightly. And after so long, you have to again boost it up. So you spend a lot of time and energy and infrastructure to keep things in the orbit. Now, that is the good thing about Lagrange points. And my feeling is in the next 50 years, you will see a lot of use coming out of those Lagrange points also. Now, here in brief is my view, what is going to explode. It'll be like a big bang in the next 50 years. We already are having, Chandra, for example, and Hubble, and now we'll have James Webb telescope, which will be incredible telescope, very expensive, and will take much deeper, will take us much deeper into the universe. So exploration will continue for the solar system and for the universe, so galaxies, black holes, you name it. Then the Earth orbit and these Lagrange points that I mentioned earlier, you will have observation satellites, a lot of them observing Earth, observing space. You will have human labs like International Space Station. China had a space station. Russia had a space station long ago. We had in US had Skylab. So these things will continue where labs will be built and recreation. People will build hotels, and there are some people who are literally working on that so that you can take a trip to the low Earth orbit and come back. Of course, when I say this, it could be also geostationary orbit or low Earth orbit. All are included in that. So tourism will be a point. Moon and Mars mission technology development, you need, for example, we are doing a lot of technology development in the International Space Station, and that will continue to happen because this is the nearest place where we can try out some things, see if they work out in temperature environment, in vacuum, in radiation environment. Then communication infrastructure. I got to take a minute here. We have just an article got published in on October 23rd in LifeWire, I was interviewed. So were the CEOs of Google or the directors of Google, Amazon, Microsoft, and Facebook. What was this about? All of these companies, Google, Amazon, Microsoft, Facebook, are getting into space big time. Why are they getting into space? They are not space industries, but they are looking to that communication and GPS and mapping of the Earth as a big thing that will explode, where data can be processed in the orbit, data can be stored in the orbit, data can be brought to any point in the orbit. You are seeing SpaceX has sent so many satellites, and so has ISRO. So that communication and GPS is going to explode. And again, then comes the Space Force. In America, we have now, like Air Force, we have Space Force, and you can imagine what that will mean for the low Earth or geostationary orbit. So in view of time, I will keep going. So moon, moon to me, long time back, 40 years ago, I had just joined NASA, and one of my bosses told me, Kumar, what is moon good for? You know, we hadn't even finished all the missions. And I said, it'll be a best location to locate, for example, telescopes, observatories, because it's vacuum. You don't have this problem of atmosphere, ionosphere, and so on and so forth, magnetic shield over the Earth, so you can see more clearly. Then scientific and technological labs can be put on the moon. That will require that special environment, for example, cold or something like that. You can put in a place where the sun never shines, and you will have temperatures way below where superconducting materials will be superconducting. Manufacturing and testing. What for? Maybe take to Mars, maybe build structures on the moon. There will be a lot of that activity you will see. In situ resource utilization, which means you will take the dirt from the moon, try to see if you can grow plants, get the water out of moon's polar regions or wherever it exists. So then it will be a test bed for Mars human missions. You will try to perfect your hardware, software, whatever it is, and even test the human conditions and human physiology on the moon before you commit yourself to Mars missions. Mars, of course, exploration is going on. You have seen so many robotics and robots roaming around on the Mars, and satellites going around gathering the data. And of course, the next frontier, human missions to Mars. I say missions because it's not going to be only one nation. Other nations are going to try to do it. By the way, on the moon, my thought is in the next 20 or so years, you will see both Russia and China, maybe even Japan going to moon with humans. So now, what are the overarching technology drivers for exploration? When I came to NASA, I was kind of initially, I didn't understand why there was so much technology probably on the Earth. We never even consider it for space sometimes. Why is that the case? And here is just a list of things that I want to go quickly with you. Gravity. You go to the low Earth orbit, you are in microgravity. So it has its own effect. You know, over here, if I wash my clothes and hang them, water will drip down. Over there, it will not. Even drinking liquids is such a different thing. Temperature. On the International Space Station, when the International Space Station is going around, it's going at 7 kilometers a second. It takes about 45 minutes. It's in the sun, 45 minutes in the dark. So a day for International Space Station is about 90 minutes. and imagine the temperature cycle. If you are for 45 minutes, you are about 300 degrees F plus, and 45 minutes, you are going down to minus 150 or so degrees F. Radiation, we'll talk about that, is a big, tall pole. We haven't solved it yet. Vacuum. When you have vacuum, and especially this is for the if there are children who are in still high school, when you have something outside, there is no air, inside there is air, this inside air wants to go outside, and therefore your structures and everything else you have has to be a different strength and quality and so on and so forth. Dust, I will talk about that. Dust storms on the Mars, I will talk about that. Dust and dust storms are some of my favorite topics. Mission cost. I learned the hard way. When we first scoped a mission to Mars under George H. Bush as the president, we found out that reducing mass is critical to reducing the cost. If you don't do that, your costs explode. You can see if you send a kilogram to low Earth orbit, probably, lakhs and lakhs of rupees. And when you send it to moon, multiply it by another factor. And then when you send to Mars, so mass is to be reduced. Make everything light. Size. Reduce the size, because then you can compact it and you can launch it easier. Power consumption. We don't have a power company up there in space. We depend on solar power mainly, and maybe we'll go nuclear one of these days. Some tests have been done, and I know Russians flew a couple of times, nuclear power. So, but power consumption has to be reduced. Everything has to work on very little power. Long life, because if we spend so much money and effort getting something to in space, whether it is orbit or moon or Mars, it has to last longer. Reusable, hopefully whatever you send there, because it's not Earth here, we can throw the nail and get another nail. We don't have that luxury there. We have to make things that are reusable somehow, put them in that cycle. Now, recyclable. Recycling is a big thing. And it will come out in some of these view graphs. But anyway, recycling means take urine and make it water, so you can put it in plants, or you can drink it, whatever. In situ resource utilization, I hinted at earlier, on the moon and Mars, we want to take the whatever resources available and use it to the best of our ability. High degree of autonomy. I want to stop here and say why that's important. If you send a signal to Mars at the longest distance, it will take 22.5 minutes. Coming back another. That means 45 minutes are gone by the time I said hello and I get an answer back. So the point is, you need a lot of autonomy, you need reliability, you need safety. Safety. Safety is a big thing, and you saw what happened. We have had 3 human missions that failed: Apollo 1, Challenger, and Columbia. And then we had the Apollo 13, and luckily we saved the crew. Human agents and amplifiers are where you have robots and you amplify the work of a human being, and there are many programs that need those. Thriving in space, I told you, this just came out, and time, I have very short time, so I will go very quickly. There are 5 things that they are talking about. The reason why I brought these in focus here, and this just came out in November of 2020, this year, is to tell you how people are now thinking of space in a big way. And big companies have been formed now, like SpaceX. We already had Boeing, Lockheed, and so many other companies, but now we are seeing explosion of other companies. And that will continue. So communications is a big thing. And in that big thing, radiation hardening is something for hardware and software. Low cost, because costs keep exploding. In space connectivity, I have a chart on that. Food production is a big thing. How do you produce food? And I have a chart on that. It's not so simple to produce food on Moon or Mars. And taking food all the time from Earth is impractical. It will explode the costs. And so you have a lot of technology right here, large scale food production. And the good thing about plants is they give out oxygen, which is so good, and they take carbon dioxide, which creates headaches. By the way, we found out in NASA, if the carbon dioxide content in the International Space Station goes more, astronauts come down with headaches. So now manufacturing is another big area on the Moon. Everything has to be radiation resistant. 3D printing is becoming very popular now here on the Earth, and so people think in the on the Mars and Moon we'll make plastics, metals, ceramics. We might take some raw materials from here, but finding the right raw materials is a key to the success of manufacturing. Now, the mantra they are saying is make it, don't take it. Make as many things as you can on the Moon and Mars so you don't have to take them. Bioprinting, we did some of the bioprinting in International Space Station, and that's showing some promise. Mining of what? Need for demand. Why do you need water? Who are you going to sell? If you may get water from the Moon, it's not a simple process. It's a very complex. I have a complete one presentation for 1 hour on just water production. Mining of metals for the use in space and Earth use. That's a big thing. And so mining, how do you do mining? Here on the Earth, it's not a simple process to mine anything. When you see mining gold, you will see how tough it is. And mining things on Moon and Mars is going to be a very difficult thing. Then they talk about transportation, and that's a big thing. How do you make propellants, for example, other consumables? We have on lunar poles, we have water ice and other consumables. I have a view graph on that. How do you harvest these things for make methane or something like that, so that becomes a propellant? The sun power. Now we are talking about making megawatts out of sun power. And you probably know that on the Moon and Mars, the sun angle is such that it's not that high a density of sun power. So Mars atmosphere has carbon dioxide, and surface has water. So how do we get liquid oxygen out of that? How do we get liquid hydrogen and methane? Now, for the kids who are hopefully listening, liquid oxygen is so good because when you liquefy oxygen, you can take little space to have a lot of oxygen. And oxygen is so important for life and many other things, and propulsion also. So that reminds me of a joke I remember from Bollywood. इसको liquid oxygen में डालो, liquid इसको बचने नहीं देगा, oxygen इसको मरने नहीं देगा. So remember, liquid oxygen is a big thing. These are called cryo rockets, and there's a lot of demand for going liquid oxygen and liquid hydrogen. Harvest asteroid resources. Now, this is what these companies, 5 people were interviewed in this article, and I'm going back a little bit. So the areas they covered was transportation, mining, manufacturing, food production, communications, 5 areas that they thought. So let me give you a flavor of the technology and engineering. I hope you are ready for this. There was a movie called The Martian. The Martian showed that it's a piece of cake. You can grow things on the Mars. Wow. No, not that easy. This article was just published, and the publication date is November the 18th of this month. And it's called Forming Our Mars. It's a publication in Science News. So when you have this simulated Mars soil, it is very hard to grow anything in it. We don't have Mars soil on the Earth. We have some soil. We brought 6 times some dirt from Moon, but that is so expensive we can't afford to use it for any other thing than research. But we simulate, when we produce simulated soils like Mars soil, it's very difficult. Now let me go show you how tough it gets to grow plants. Plants need fertilized with mixture of nitrogen, potassium, calcium, and other nutrients. If you want to grow something in Mars, you have to have these extras put in it. Otherwise, nothing will grow. Then you have Mars. Dirt has very high pH. It's about 9.5. You need, for natural soils here on the Earth, less than 7. And to get there, you need sulfuric acid. And इसको acid डाल दो, फिर इसका pH decrease हो जाएगा. वो acid कहाँ से लाओगे? It's not so simple. So some people think urine will have some sulfuric acid that can be put in the dirt of Mars, for example, to grow plants. Okay, you are now seeing nitrogen, potassium, calcium, other nutrients. Then you have a need for this sulfuric acid. Now, another problem that comes up is calcium perchlorate, and it's a toxic salt. Now, here on the Earth, microbes eat that salt, and therefore we have these bacteria in the soil that allow the plants to grow. Once you have salt, you lost all the possibility of having plants. So now you have to do something in order to have these microbes or equivalent technology that will give off, they give off oxygen, and these are bacteria taken from Earth to Mars. Maybe then, now you are seeing the whole menu is tough. So it's not quite as easy as it looks in the Martian. That was the point they were making in this article that just got published in the Science magazine. Okay. Now, when you talk about communication architecture, you're looking at, for the Moon, you have to have local networking on the Moon. Then you have to have a trunk line between the Earth and Moon. Maybe sometimes between the Moon and Mars also. I didn't show it here, but that is a possibility. Then you have trunk lines, and they have your local network on the Mars, and we have a lot of other possibilities. But the biggest one is the Earth, low Earth and geostationary Earth, and these Lagrange points L1 and L2. And this infrastructure, keeping it going all the time, is not so easy, because these are moving, they're not stationary, and you have to provide the connectivity. A lot of times people miss one point, and I'm very particular about that point. That is, the data is exploding. How do you transfer this high quantity of data? And it's not so simple. I have quite some experience in communication. To design these communication systems that are cost effective is very tough. So future challenges, I have very little time to cover this. Again, size per mass. What we found in NASA is that if you have to go to Mars or stay on the Moon for much longer period of time, you do not have the technology presently. You literally have to do revolutionary step in technology, not evolutionary step. Size per per mass. We have to reduce the mass and increase the size in certain cases, like solar sails, like antennas. Strength per mass, per kilogram of strength, per kilogram of mass, we have to have tremendous strength for human habitability or launching capability and so on. Capability per mass and power. Power is a big thing. Intelligence, we want intelligence and autonomy in all the new things that we'll send in space. Again, time is getting short, so I'm going to have to follow a little faster. Human robotic systems, surface mobility. Humans, you cannot let humans go all the time outside because it's vacuum on Moon and there's a little partial air, but you can't breathe it on Mars. So you have to have robots that do are mobile, that are can transport the crew, that can take the payloads, large scale handling of big things. If you are manufacturing things, that's a big infrastructure. You have to have flexibility. Sometimes you need that agility in these robots so that they can hold an egg without breaking it. And human system interaction, they have to interact with humans. And if a robot comes and hugs you and kills you, we don't want those kind of things to happen. I'm exaggerating here, making it humorous. The point is, we have to be trusting a robot to do something like we trust a human being. We are doing a lot of work on robots for the last 40 years. And this is a NASA Robonaut that we used in space station to do certain things, and it's working really great. International Space Station, ISS, is, you can go back, you can Google, you'll see that for the last 20 or so years, ISS has contributed, has verified a lot of technologies, especially in situ, recycling of resources, like I was talking about urine and recycling air and things like that. That work is going on very well, and we'll need recycling of resources. Now I will cover so fast these key technology needs for Moon and Mars exploration. Structures, lightweight, inflatable. See, I told you size. So if you make things like umbrella, where they can collapse down and then you expand them, we have something like that based on carbon fibers in space right now. And these are collapsible things. You will expand them and they will become a room on the Moon. And that inflatable technology is showing a lot of promise. But again, there are a lot of questions like radiation. Will it stand the temperature? Will it stand the vacuum outside? Protection for temperatures and radiation. How do you protect these structures, and how do you protect humans when they are outside, robots or whatever? Propulsion need, we are working, NASA is working on space launch system, which will be like huge rockets are needed to go places like Mars. Power. Again, I was trying to say lithium ion batteries. We are making power in such a way that it is safe. Sometimes these batteries explode. You must have seen on these iPhones. We have lots of problems. I'm running fast, but that's a thermal control. I learned the hard way. Boys and girls, especially in high school and college, please listen. You cannot easily reject the heat in space. Over here we have conduction, convection, and sometimes radiation. All three things take away the heat. Over there, it's very hot. You will conduct to what? There is no air. And if you want to conduct to some plate or something, now you have to take that plate. So conduction, convection, it is on the Mars, there might be a little thing, but for the moon, not possibility. So what do you have? Radiation. So that those surfaces, you have to design the engineer the surfaces such a way that heat can be easily rejected to the sky, which is sky temperature is like 2.8 or something degrees Kelvin. So it's cooler, so you can radiate it. Avionics and software. India is great in software, but still there is autonomy, rendezvous and docking. Autonomy is a big thing. Radiation hardening is a big thing. Reliability in software is a big thing. You're seeing how many failures we have, software failures here on the earth. After using the software thousands and millions of times, still it fails. Environmental control. How do you control for life support inside the habitability module, the environment? I told you carbon dioxide, one little thing goes higher and you see problems coming up. Oxygen goes down, you see problems coming up. Crew support and accommodations. This extravehicular activity suit is a big technology item. We're working on it. Mechanisms, especially for very low temperatures like South Pole, North Pole of moon. How do you design things that will tolerate that extremely low temperature? In situ resource utilization, we talked about that. That's a big item. Oxygen production and so on. Water production, not so simple. You keep heating the soil, you will get other gases also. Analysis and integration, then operations. We don't pay much attention, but Johnson Space Center is an operations center in a way. You know, we know how a mission operation becomes this difference between a failure and success if you don't pay attention to operation of a mission. Almost getting out of time, but human support technologies. For this slide is for humans. Personal biomedical monitoring of everything, you know, from heartbeat to EKG, encephalographs, you name it, temperatures, blood, urine, all these things. Personal countermeasures I give. Believe me, on each of these items, I have a presentation. The countermeasure means the bones get very fragile in zero gravity. On the moon, we have 18% gravity. On the Mars, 38%. So the muscles will be very weak on both moon and Mars, but in the International Space Station, they are very weak. Within a week, you will see the difference. The bones get brittle, they lose mass, muscles get very weak, heart gets weak, so many things. So you have countermeasures. We designed this treadmill, we are designing bungees and so many other things. Drugs, we're using even medication to countermeasure this. Basic medical research, a lot of things, major medical operations, life support is a big thing. Toxicology, toxic materials. We are a factory of toxic materials as human beings, and even some of the systems give toxic gases out. So how do you treat them? So it looks like, people can show this region, South Pole, and it has water, it has many other metals and so many other things. So there are resources, but where is the engineering? Where is the technology to, where is the infrastructure? This is going to take decades to be able to mine the water, to be able to mine these metals, to be able to have structures, to be able to make enclosures, to be able to grow plants, whatever it is. I just wanted to show you, people can put things on the picture and show you that they have grown plants and this and that. Nothing so easy. This will be challenge for engineers, scientists, technologists, you name it, for the next 50 years. So this is one of my favorite charts. Is this dirt is not so simple. Not only when you start walking in it, it's hard to walk. Forget it. When you have a vehicle, the tires, how do you design the tires so they don't get stuck in this dirt? But more importantly, this dirt has very fine glass, silica in it, and that can cut the on the shoe, just between the shoe and the leg part. We saw some tear in astronaut Harrison Schmidt's Apollo 17 mission. And then he got a little bit sick because some of these materials have toxicity in them, and they will get in everything. If they get on your power panels, solar power panels, you will lose like 70% of the power instantly, because it's a black dirt and it won't let sun's light get to the photodiodes. So dust is a big issue health-wise also. And cosmic radiation, you have these high energy protons and heavy ions that come from sun primarily in our case, and they hit these structures, they create secondary emissions of heavy ions, and that reduces the strength of the materials. And when they get on humans, there is a lot of loss, cancers, and we see even some DNA gets damaged, and at the cell level, the chromosome level, there's a damage. So the survival of astronauts is dependent on it. And so there is a lot of research going on. I was head of a space radiation committee for the Johnson Space Center, and we had 50 people working so hard just to understand. Now we have understood a little bit more about the environment. We still don't have solutions. Some say hydrogen stops it, some say water has hydrogen, therefore we can do that. But if you try to stop it with metal, you will need a lot of mass, and that becomes an impractical problem cost-wise. So my favorite topic, food. Food is not so easy to preserve for long periods of time. Here I have two charts. We came out with all kinds of pouches. We even came with this aluminum foil that you see in many of these things that now contain potato chips or something else. You will open and see aluminum foil. A lot of that research was done by NASA to create enclosures which keep things fresh for a long period of time. For meats and other things, we even radiate them with nuclear radiation. So long duration food systems still need a lot of engineering solution. Otherwise, you will have microbial growth in them. They will lose their nutrients. So that's a question. And a lot of times our astronauts want fresh things, like they would like to have an apple or something like that, fresh. How do you keep that fresh on the moon or Mars, going to Mars? These are the issues about food. And then food production, I already told you how tough it is going to be on moon and Mars. So when you are designing human factors, Professor Sridhara, how are we doing on time? I want to stop 10 minutes. It doesn't matter. I will cover the end 2 slides. But how are we doing on time?
Just another 3 minutes, sir.
Okay, so I will go to last charts. Now, I will walk you through the rest of the charts. You're getting the flavor. The flavor of this presentation is there is a lot of challenge in designing systems, engineering challenge, technological challenge, new technology needed, revolutionary to reduce the mass, size, increase performance, have safe systems, have autonomous systems, all these things. be able to do the things that we want to do. We don't have those kind of systems. So I have here a lot of slides, and I'm going to go through them. Here is automatic rendezvous and docking. How do you dock two spacecraft together? You have to go to the moon. You will need a lot of docking, taking things to the orbit, then docking. There's a whole bunch of technology like that. Even landing on these is a big problem. We could have lost one Apollo mission. We were lucky by only about half a meter. If the leg would have gone into the crater, you would not have seen the astronauts back again, probably. So you see, there's a lot of hazard in landing and taking off. Especially dirt also comes, when you have these rockets, they give a plume of dirt. So in situ resource utilization, I think we beat this a lot. Is not an easy thing to grow things, to use the soils and water of these planets. Dust is a big thing. I have been even trying to understand how these dust storms are made on the Mars, and trying to understand what would be the trajectory of one dust particle as it goes around. It's really wonderful mathematical and physics problem. But anyway, that's my favorite thing is dust, because dust is going to really spoil a lot of missions if we don't solve the problem, because it will come in everything: spacesuits, truck, any vehicle, robots, everybody will be affected. Life support, and I have advanced environmental automation. How do you make things automated? Because in space, the time of astronauts is not so cheap, So then intelligent systems. Now, since I have a couple more minutes, I must tell you this. China just on the 23rd of November, those of you who are space enthusiasts, this should ring a bell how far advanced China is getting. On 23rd of November, they launched a big mission, March 5 heavy lift launch vehicle to the moon to gather moon rocks, 4 pounds of worth, and bring it back to Earth. It's on the way to moon. It will stay there for a few hours. The scooper, the thing that will come back, the whole mission is going to take 23 days. And they will be the 3rd country in the world to have the moon samples. They already had a space station. They abandoned it. They sent a couple of astronauts to it, first one and then a couple more. And I believe they sent a lady astronaut to that station. So China is preparing a human mission to moon. And my guess is it will happen within the next 10 years. I want to end this presentation with my personal note. And that personal note is this. As I have been working with NASA, I realized all the way from Apollo and now on the Mars also, we keep putting these things on the surface of the moon. We never brought anything back other than a few pieces of dirt, So now the question is, China goes there, India goes there, drops something, America goes there, Russia goes there, Japan will go there. What have you? It will become a bed of junk. This is what we did to the earth. We polluted the earth. And if we had from the beginning thought that pollution is bad, maybe we would be much better off on the earth. And so my personal appeal, whenever I give this this type of presentation, is have technology available to scoop all this. Guess what we have done in the low Earth orbit? All these satellites which are not functioning are there. The junk is there. Sometimes the pieces are there, so you have a whole bunch of junk accumulating around the earth also. So my personal appeal is that we better leave the moon and Mars as pristine, as clean as it was before we went there. And so what can I say? Thank you very much. My last slide says, we are on the earth. We will have a staging uh, planet called moon, and we will be going way out there to Mars and many other places, hopefully asteroids also. Now, I have to apologize because I was so fast, but what can you do? I was telling Professor Sridhara, I had 85 view graphs. I reduced it to 40 or something. And now you see, I couldn't even cover all of them. So I'm done, sir.
Thank you very much, sir. In fact, this is a rare opportunity for all of us. We are listening to such a renowned person, renowned scientist who has worked in NASA for such a long time and who has been awarded with so many rewards also. There are some interesting questions I will be sharing one by one, sir. Could you please share some insights on what kind of space technologies can be leveraged for addressing concerns on environmental presentation, global warming, etc.? And this is from Dr. Barnamala Saha, one of our faculty members.
Okay, we see that's another topic that I covered and I worked on in that area for almost 20 years, called technology utilization. This recycling, for example, of resources will be very great thing for Earth, where you recycle the resources, right? So global warming, once you start recycling the resources, you will see that we will not need that much manufacturing to be done. If we do the recycling very intelligently, therefore, that infrastructure that is creating global warming could be reduced by recycling the resources. And also we have to pay attention. All our activities should not result in polluting air, water, and land. And NASA is doing that in the sense that we have to do it in order to utilize our resources. And over here, that technology can come directly over here. Let me end by saying this. Water purification is an example, great example, that where we have taken the NASA technology and utilized it here. There's a company called Ionics. They can put any, when there was this big earthquake in Pakistan at the time of about 10 years back, we did water purification using NASA technology. Go ahead.
Sir, there is one question from Chirag Bhatia. When can NASA expect to send humans to Mars? As Jeff Bezos and Elon Musk have told us, by the year 2022, they are expecting to send the human to Mars. When it is expected?
Nobody can give a date, but the preparations are going on. We thought by this time we would have a mission to Mars. But if you are asking my guess, I'm not going to tell you that what NASA knows or what NASA is saying. But my guess is give and take 30 years. In the next 30 years, one of the reasons will be that we will need the moon to check out a few things, and that will take some time.
Yeah, there are common questions like from the students here. How do we reach NASA? Suppose, can I get an internship in NASA? And how do I join NASA after my courses? Program?
Okay. First of all, that's a very good. All questions are incredibly good, but this question of joining NASA, I must be very clear, because a citizenship is needed. I cannot join ISRO. I am a U.S. citizen, and it works both ways. So what happens is, but one of the greatest things that NASA has is the ability to use intelligence from all over the world. And we did that during Apollo, all over the world. Anybody that was expert got tied in. The way you do is you go www.nasa.gov, and you will see postdoctoral fellow advertisements and advertisements for students to apply, foreign students to apply. That's the best way. But joining NASA like I did, at the time I joined, I honestly was not a citizen. But within 1 week, NASA got me citizenship because that's something that had to be done.
There is an interesting question. Sujal Singh, can ISRO overtake NASA in near future? In what way? I think they.
I cannot speak about that topic, but I will tell you this, that Honorable Modi, Prime Minister of India, said that, and this is a big statement, that India wants to be the Walmart for space technology. Given the fact that India is now thinking of sending humans to low Earth orbit in 2022, that may change a little bit because of this corona problem. But my point is, it's not a good goal to take over somebody. I don't like anything. It's not a race, running a race. You run on your own pace. And I like that attitude of China. They have been working so hard in the last 30 years on different things. And they made things happen one step at a time. And India is also working very hard. But let me end by saying this. There's also a question of resources. How much you put in this. Even in United States, the money that we are putting into NASA is less than 0.5%. So less than 0.5%, see how much work we are doing. But that's why when I was interviewed by LifeWire, Google coming in, Amazon, Microsoft, Facebook, SpaceX is already in. That is going to bring private capital into the thing. I think ISRO has realized that, and they are now privatizing quite a few things.
There's a question from Dr. Kushbu, our faculty member. She asked our computer science students how they can actually take any internship or projects from NASA.
Again, www.nasa.gov is the way to go. Ames Research Center uses a lot of foreign students. That's where most of our software, they are tied with Google. Ames Research Center is in California. And so I say, watch. A lot of these topics are advertised. I was the postdoctoral advisor to NASA, and I would advertise I graduated about 10 or so doctoral and postdoctoral candidates came. One of them worked with me for 4 years, Mary Collin from France, Dr. Mary Collin. So you see they advertise what NASA is advertising for software. And if you have the capability, find out who is advertising, where is, mostly it will be Ames Research Center, and then contact them, apply. Something they will do. They will manage to get the talent.
Okay, and people are asking like, is it really possible for humans to live on Moon and Mars in future?
Live is one thing, but going there, staying there for some time. See, if you're talking about living like humans who are living on the Earth, my personal thought is very different compared to many of these movie makers like Martians and so on and so forth. And many of the dreamers, they say, make Mars green and this and that. I think we should try to make Earth green. We have a desert in Rajasthan, right? We have here what we call many deserts, Death Valley in California. If we cannot have resources here on the Earth and utilize our own land, our own, deserts, green them, what's the idea of living on the Moon and what's the idea of living on the Mars? What does it serve? Going there serves something. Maybe we will find helium or certain types of things on the moon that might be applicable, maybe great for us to have here on the Earth. So I'm for that. Exploring Mars to see if life existed there, or if there are some resources that we can bring back, or same thing applies to asteroids. I'm for that, but I'm not for, greening this planet and greening that. I'm not for that.
Yes, because time is moving up, I'll just take two more questions, sir, if you don't mind. Is there any multiverse? As we can see, we have other galaxy other than Milky Way, and could we have another Earth-like planet? This is from Rishabh.
Okay, that's all these questions are really good. It's guess, and I don't have appetite for guessing. I'll be honest with you. What we know, what I have studied for the last 50 years in NASA, Earth is in a very unique situation. And as far as we can see, we don't see a planet in that unique situation anywhere. So, second, let's say there is a planet and it is going to take 1 billion years to reach there. If you found, first of all, such a possibility. Now, what is the idea of that planet being there? Even if it takes 1 million years, we know it's not going to be in the solar system. That much we know. So my point is, in a very different way, what I'm saying is, dreaming is good, but dreaming for what? When will we reach there? And why would we do all that when we have people here on the Earth that need help? My fascination, my attraction for NASA, 90% was because the technology we have for space is used here on the Earth. I can prove to you. We revolutionized everything on the Earth. So it's not a wasted effort. But only 10% of is exploration. But 90% was utilization of, if you can exist on the moon, you can exist in Sahara Desert, you can exist in Rajasthan Desert. You can do great things on the Earth because you will recycle things. You will be able to live on Himalaya Parvat. Next question.
There's a question from Sonia Chalia. She's our faculty member. She says whether NASA can pull up and team up with other organizations to address the issues of global warming, water scarcity here on the Earth. I think you partially answered it earlier.
NASA is already teaming up. European Space Agency and many other space agency. Global warming is a threat, but I have a presentation that I give where I show that the natural things that are happening here on the Earth, which are dozens of them, tsunamis, earthquakes, storms like you call them typhoons, we call them hurricanes. There's so much going on here. The volcanoes are coming up. I have 2 charts full of them. And if we cannot address that, those are natural things happening, right? They're going to happen. And how do we, global warming is not the only threat. And what I'm concerned about, and I want to tell openly, is that that is one of the threats. But then there are at least 10 major threats, natural threats. There is a fault line that hit slightly Nepal. See what happened, 8 point some earthquake, right? And see what happened in Pakistan 10 years ago. And these are active, and there are fault lines under the ocean, and that give you those tsunamis. Bottom line is, if you solved global warming, you still will not be able to do much about, unless you pay attention, those natural things which are happening. We're losing every year so many lives in the United States with these hurricanes. We have tornadoes. We have a tornado alley, we call it, in a state called Kansas and Oklahoma. I was in Kansas for 4.5 years. And these tornadoes, once they go in a town, you will see nothing. It's flat, gone. So I rest my case. Global warming, we must pay. If we pay our attention, and NASA is linked with many organizations, monitoring is a big thing. First, you got to know what is the problem. And that NASA is doing great in monitoring global warming.
Thank you very much, sir. We have come to the end of the time, and there are other questions which I think I will be posting you, and please, I'll get some solutions from you and then post them back.
I have one request. I would like to have some feedback, a little bit of feedback from time to time.
Sure, I will
is good.
I will get the feedback, sir. We have the feedback forms. We will get it. And
again, this question of joining NASA or partnering with NASA, it's not difficult. It's easy. But you got to go and see. We advertise everything. I was advertising topic after topic, and look, I had a French lady for 4 years that worked with me, and so many university fellows came, professors came to work with me.
Thank you very much, sir, for having joining us. And in fact, I'm really moved by the enthusiasm which you have, and also you are trying to motivate all juniors like us. And of course, my students also are very, very happy with you. Thank you for joining us. Probably we'll have one more session with you if you don't mind, little later. Thank you very much,
Sure.
sir. And
thank you, and keep thinking. Space is going to explode, and these companies like Google, Amazon, Microsoft, and Facebook wouldn't come in for nothing. SpaceX, no, they are profit oriented. They know there is something great happening, and that should be told to the students.
thank you very much, sir. We'll close down. Thank you.
Thank you.